Hello and welcome back to episode 1 of Polynomials. Today we're going to be talking about types of numbers. Now, I realise many of you may not be fully acquainted with the different kinds of numbers. They are essential for what I'm going to be talking about in the next few episodes, so I suggest that you listen and take notes. If at any time you need to take a break, I recommend you pause the video, take a short break, and then start again when you're ready. In this episode, I'm going to give you an overview of the types of numbers. So, first we have the natural numbers, denoted by this little n. It's a weird n, but that's because it's the symbol for the natural numbers. Natural numbers are 1, 2, 3, 4, etc. So the positive integers basically just means whole numbers. So natural numbers are the positive whole numbers. It's debatable whether 0 is a natural number. I personally don't think it is, but then again, it's debatable. With natural numbers, we can perform a number of operations, but there are some operations that we can't perform. By operations, I mean we can add natural numbers, we can multiply natural numbers. We can't subtract natural numbers because, for example, if you had, say, 3 minus 6, that would be minus 3, which is not in the natural numbers. You can't divide either, because if you did 3 over 6, that would be a half, which is not in the natural numbers as well. So you can't do that. Next, we come to the integers, denoted by this weird z. For the integers, we can now subtract, because we have negative numbers, so all the way to negative infinity, which isn't a number, because you can't reach infinity, it's just a concept. But all the way from negative infinity, I'm just going to do scale negative 2, negative 1, 0, 1, 2, etc. 0, again, it's debatable, so I'm going to draw a little question mark, and we can now subtract, because if we do, once again, 3 minus 6 is minus 3, which is a member of the of the integers. I should say at this point, I'm going to introduce some new symbols, and if you are at all unsure about the symbols, I will attach a symbols sheet to each one of the videos of this series. So don't worry about that, and remember to look at that sheet. So next we have the quotients, which are of the form a over b for all. That's what this upside down a means. For all a, b belonging, that's what this symbol means, belonging to the set of the integers. So I'm just going to draw an integer sign. So that's a mathematical phrase, but it describes the quotients. Quotients are also called the rational numbers, so we can't yet have irrational numbers like root 2. Root 2 is not allowed. But we can multiply, we can subtract, we can add, we can divide, and that our 4 basic operations are now possible with the quotients. Next, we have the real numbers. Don't worry that I just started mentioning things being real. I will come on to what is not real, and I will explain it all to you, so I wouldn't worry. So we can now have the nth root of a positive quotient, which basically means we can have anything belonging to the quotients that is also positive, we can now put in an nth root. By nth root, I mean square root, cube root, quart root, etc. So we can now add, multiply, subtract, divide, and nth root, the 5 basic operations which I will talk more about later. Not in this video, but in a later video. Next, we have the complex numbers, and this is what happens when we are now able to nth root all of the quotients, even the negative ones. So if we have root -1, that can be denoted as I. Don't worry, whenever you see I, just think it's root -1. So, for example, if you wanted to square root -9, you would say that's square root of -1 times the square root of 9, which is just I times, that's what this little dot means, I times 3, which is 3i. So that's the simplest way of looking at complex numbers. Complex numbers are usually of the form a plus bi with a real component belonging to the real numbers and an imaginary component. The imaginary coefficient, so this b here, will be a member of the quotients, but we call it the imaginary coefficient. These are represented on something called the Argand diagram, with an imaginary axis rather than a y-axis, and a real axis. If we had a plus bi on this, we would be a squares to the right, or if a was negative, we would be on the left side. And we'd be b squares up, which is here. Or we would be b squares down, because if b was negative. And we would be here, like I've just said. And they are denoted by a radius and an angle theta. Theta is a Greek letter, and we use it for denoting angles. Before I forget to say this, over the next few videos, there will be a few sections that you won't be able to do if you haven't covered complex numbers. If that's the case for you, I will try to put in some timestamps that you can skip to miss out on the complex wilderness that I will be delving into. Anyway, thank you very much for attending episode 1 of Polynomial Party Time with Peter, and I will see you next time.